The following video regarding pH meter calibration, acids, bases, and buffers was completed by Kapil Nathan, Kira Johnson, Taylor Hannon, and Danique Sanders, students in the Chemistry 118 lab course at the University of Alabama at Birmingham. The first step that the group took was to calibrate the pH meter in order to accurately gauge the readings of the compounds. The group did this by first removing the bulb of the pH meter from the stock bottle, thoroughly washing it with water, cleaning the bulb, and then putting it into two buffer systems. As shown, the group first put the pH bulb into the pH 7 neutral buffer. When the group put this into solution, they pressed Calibrate Now on the meter in order to set the value. The group then re-washed and cleaned the meter in order to get the second value. The group put the bulb in the pH 4 buffer and then pressed Calibrate Now. The pH meter showed a reading of approximately 4.0, giving them the green light to proceed to the next task. All group members performed at least one calibration of the pH meter prior to starting exercises 1 and 2. Having finished calibrating the pH meter, the group then set out to find the pH of 4 different compounds. The first group member poured about 40 milliliters of acetic acid into a beaker and measured the pH to be approximately 1.39. Independent of the first group member, the second group member calibrated the pH on his own and decided to find out the pH of the second compound provided, which is hydrochloric acid. The group member poured about 40 milliliters of hydrochloric acid into a container and then measured the pH to be approximately 1.25. Because hydrochloric acid is a strong acid, its pH would logically be lower than that of a weak acid like acetic acid. The third group member also independently calibrated the pH meter in order to get her own accurate reading. The group member chose the third compound, orange juice. She did this by pouring approximately 40 to 50 milliliters of orange juice into a container and measuring the pH, which was approximately 3.82. This wasn't a surprise given orange juice's rather tangy flavor and the presence of citric acid. In fact, the general acceptance is that orange juice's pH is approximately 3.9. The fourth group member also independently calibrated the pH meter and then chose apple juice for her compound evaluation. She poured approximately 40 to 50 milliliters of apple juice into a container, as shown, and then measured the pH to be approximately 4.20, which isn't a surprise given that orange juice has more citric acid, so the pH would logically be higher. The group then noted down the pH of each compound in their notebook. Then use the formula 10 to the negative pH to find the hydrogen ion concentration. The lower the pH, the higher the hydrogen ion concentration, because a lower pH indicates more acidity. Continuing the concept of acidity, a weak acid is an acid that doesn't completely dissociate in solution. Their pH is usually greater than 3.5 but less than 7. Equilibrium exists between the weak acid, water, the hydronium ion, and the anion of the weak acid. Equilibrium favors weak acids and bases due to their lower energy. A weak acid will also more readily react with a strong base, causing less product of the dissociation left to complete the reverse reaction and thus make more reactants. A strong acid, however, is an acid that completely dissociates in solution and its pH is usually less than 5. There are also 7 set strong acids. Ionization is not reversible in strong acids because when a strong acid reacts with a weak base, this causes more of the product of the dissociation left to complete the forward reaction and thus make more products. The group's next exercise was to compare the pH of water to the pH of a buffer. The group first measured the pH of tap water to be 7, then made a buffer consisting of 30 milliliters of 0.2 stock solution sodium hydroxide with 60 milliliters of 0.2 stock solution acetic acid. The group then placed approximately 30 milliliters of buffer solution in the beaker containing water and measured the pH, then added 0.2 stock solution HCl and again measured the pH. A buffer is a solution that maintains the pH of the solution upon the addition of an acidic or basic component. They work by neutralizing any added acid/hydrogen ions or base/hydroxide ions to maintain a moderate pH, making them a weaker acid or base and keeping the entire solution at a standard pH, working by the common ion effect. When a given ion is added to a solution already containing that ion, the equilibrium shifts away from forming more of that ion. Following the collection of all measurements and data, as well as the calculation of final values, the group turned in the assignment sheet to the TA and cleaned up their lab space by returning glassware to the appropriate location, appropriately disposing of compounds used, and washed their hands. In this experiment, the group learned a lot about acids and bases, the difference between weak and strong compounds, how a pH meter works and is calibrated, and how buffers work. I hope my definitions weren't too basic, and I hope this video didn't buffer while you were watching. Thank you!